Hey everyone, hope you're doing well. Today we're going to be solving number line jumps. Let's get to it. So I've already solved this challenge. However, while I was editing the video, I realized solving these challenges live is quite time consuming. There's a lot of dead space, silent content in between, and the videos just end up being really long. So instead, I'm going to trial a format where I solve the challenge first, and then I make a recording about solving the challenge again, but in a little bit more concise way. So without further ado, let's get to it. So in summary, for this problem, we are given two kangaroos on a number line, and they are jumping in positive directions, or well, in a singular positive direction. The first kangaroo starts at x1, the second kangaroo starts at x2, and they both have different jump rates of v1 and v2 respectively. And we have to figure out if it's possible if the kangaroos can get to the same location at the same time. If it's possible, return yes, otherwise return no. So we have to complete the function kangaroo, and it's given the following parameters: x1, v1, x2, v2, which are the start and jump distances respectively, and has to return either yes or no. Looking at the constraints, we can see that x1 is always less than x2, and it will never be negative, and it's between 0 and 10,000 inclusive. v1 and v2, the jump distances will never be 0, so they will never just be stationary forever, and it looks like they can be the same. Now let's think of some edge cases. So, well, just immediately we can already say that cases, if jump distances are the same, because we know they will never meet up. For example, let's say the starting position is 10 and the jump distance is 1. Now let's say here the starting position is 12. And the jump distance is also 1. So you can see here they will never meet up. It's always going to be a difference of 2. So this should be false. The other time that we need to fail is if the starting position, if a larger position also has a larger jumping distance. Because let's say here, instead the let's call this 1, and then let's call this 3. We can see here immediately, again, this will never be true. This will be 11, and then this will be 15, 12, 18. It's never going to work. Whereas here, if we have 3 and let's make this 1, will this be 12? This was going to be 13. Oh, it works here. Let's try this. 12 and 2. So that's 13. That's going to be 14. This is going to be 16. Yeah, that works. So let's try 5 here. 15, 14, 20, 16. So immediately we can already see after this, 15 and 14, after the first jump, it's never going to be possible. So check if the larger position also has a larger jump distance. If that's true, it fails. So now that we've identified our edge cases, let's formulate a general solution. So find the larger position. So let's call this XL. Larger starting position. XL. Find smaller starting position. XS. Find a relative jump distances, which are going to be VL and VS. So X position that's larger, or larger X position, smaller X position, larger velocity and smaller velocity. Right. So that's the first step, and the way we can find this is simply with if x1 is greater than x2, we set these values, or we do it the other way. Actually, we do it like this, and we do it the other way. What's next? So now what we're going to want to do is I think we want a while. We want to make sure that while the smaller X position is less than, well, XS is less than XL. That's the first one. And then I think what we're going to want is to check if the jump distances are appropriate. So if VL, not VL, greater than VS. And we also want to make sure up here. So this is the first one we're testing here. The larger position also has a larger jumping distance. So here we're testing, make sure this isn't true. And then this top one, making sure that the jump distances are not the same. And if false, I guess. Else false. Here, what we're going to want to do is check if XL is equal to XS, and I've just realized here that there is a problem. We need to make sure that these can be equal. Otherwise, this will never pass. And then here, at the end of the while, we do XL plus equals VL, XS plus equals VS. And if this is never true, if this is never true, we also want to return false. Let's indent this all in slightly. Yeah, I think that's it. So if we ever if the initial smaller position eventually exceeds the initial large position, we know that they've already overlapped each other, and they'll never meet up again, and it's impossible for them to ever meet up at the same position because they've already exceeded each other. So I think that's it. Let's get to coding a solution. So the first thing that we need to do is find the larger positions. So if x1 is greater than x2, xl is equal to x1, fs is equal to x2, bl is equal to b1, and bs is equal to b2. Else this, let's swap the numbers around, and then oops, this one. Here we're going to need the variable names. So let xl equal 0, let xs equal 0, let bl equal 0, let bs equal 0. Yep. Okay. Now I think it was the while that we have to do next. We've done this. Yes, that's while now. So while xs is greater than or is less than or equal to xl, and then while what are the jumping distances? While not bl is greater than or equal to bs. That's it. So while the initial smaller position does not exceed the large position, and while the larger jumping distance, or while the jumping distance for the larger position is not larger than the jumping distance for the smaller position. Yep, that's correct. What are we going to do? We're going to check if the values are the same. So if xl equal to xs, return yes. Otherwise, we're going to add the values. So xl plus equals bl, xs plus equals bs. If this here is false, so if the larger jumping distance is bigger, if the jumping distance for the larger position is bigger, then return no. And then if the smaller position ever exceeds the size of the larger position, return no. And I think that's it. So let's give it a shot. Fail here. Why did it fail? while the smaller one is less than or equal to the larger one. Oh, that's correct. The larger one is not greater than or equal to it. Yeah. I do not see any problems. That's good. I don't think it's this. Let's find out where we are failing. Console.log pass. Doing that. Pass. Okay. So we know this passes. Let's try this. Okay, for some reason, yeah, this didn't work. What is it? The larger distance. Did I write it incorrectly? Let's see if this changes it. Okay, yeah. So for some reason this not screws it up. So I did it right. It was just that. So I will I'll change it around. While VS, or the smaller jumping distance, is less than or equal to the larger jumping distance. Could I exceed it? Why does this work? And not the other way around? That works. And then this one should never work. I should get possibly time exceeded here. And then here, if I change it back to this. Okay, yeah, there we go. I think I just typoed it there. Okay. So that way, at the larger value, if the jumping distance for the larger starting position is less than or equal to it, yep. Check if the positions are the same. Implement values. If the jumping distances are larger, if the jumping distance is larger for the larger position, return no. If the positions ever exceed each other, return no. Right, so everything seems to work out well. Let's submit it. Here we go. Oh, wait, no, we don't want it to be equal to it. No, okay. So, I mean, it doesn't really matter. We can do the same thing. We don't want it to be equal. That's correct. So yeah, it's definitely a little bit funny with this if statement here. I confused myself a little bit, but we figured out the problem. Yeah, we don't want the jumping distance to ever be equal. Before I was testing to make sure that it was equal. However, if we go back to what we had before, and we don't have an equals operator there, will this also work? Yeah, okay, great. So yeah, there's lots of ways we can solve this, but in conclusion, we did pretty well. We identified all our edge cases, which actually still kind of tricked us up a little bit, but we identified it. We implemented a general solution, a general format to follow with our code. We filled in the blanks, we actually implemented the solution, and it worked out quite well. Do we need all these variables here? I guess this is fine, it's not too bad. It's okay. I can't see any way to get rid of these variables. If you can see a way to getting rid of these variables and writing even more concise code, hit me up in the comment. But otherwise, I'm going to call it. Thanks for watching. Hope you learned something. Stay tuned for the next video.